Welcome back. Today we're going to be talking about anabolism and catabolism. If you haven't watched the first two videos about macromolecules, go back and watch those and then come back here. All metabolic functions in your body are either catabolic or anabolic. Catabolic reactions break down larger molecules to make smaller ones. An example of this is digestion. You might eat a steak, and your digestive system spends a bunch of time and energy breaking down that steak into amino acids. When you break down larger molecules, you end up breaking the bonds, and that releases energy. Anabolic reactions are the opposite. They build structures. For example, if you lift weights, you might hope your muscles get bigger. Building more muscle protein is an anabolic reaction. People that really want to get bulked up might abuse anabolic steroids, called that because they help with anabolism of protein. When you take smaller subunits and hold them together against their will, it requires energy. So anabolism stores energy. Both anabolism and catabolism have other names. Catabolism is also called hydrolysis. Anabolism is also called dehydration, or sometimes dehydration synthesis. We're going to look at the molecular mechanisms that atoms go through to either build or break down molecules. And guess what? It has a lot to do with covalent bonds and water. Now look at the words dehydration synthesis. Most people concentrate on the dehydration part, and yes, we're going to be removing a water molecule. But I want you to also look at the synthesis part of the word and remember that synthesis means creating or adding. So dehydration synthesis removes a water molecule and creates something bigger. So this is an anabolic reaction. Remember that all atoms want to be fulfilled. They want a full valence shell. In this example, all the atoms in glucose and all the atoms in fructose are happy. But we aren't happy because maybe we want to build something bigger. Maybe we want to store some sugar. So imagine that an enzyme grabs these two monomers and removes the OH from glucose and the H from fructose. The OH and H atoms can combine to make water. This is the dehydration part of this reaction. But what about the carbon atom that used to share an electron with oxygen? It is now missing an electron from its valence shell. And what about the oxygen atom that was sharing electrons with hydrogen? It is also unfulfilled. So that enzyme, the one that ripped away oxygen and hydroxide, will encourage these atoms to share with each other. The remaining oxygen atom on fructose will share its electron with the lonely carbon atom on glucose. And that sharing of electron creates a covalent bond between these two monomers. This is the synthesis portion of this type of reaction. The opposite is true of hydrolysis. Remember that hydro means water and lysis means breaking. So in this case, we're going to use water to break apart or keep apart the bonds holding these two monomers together. This is a catabolic reaction. The enzyme will break or lyse the covalent bond between oxygen and carbon. This leaves two atoms that are sad and lonely and looking for love and electrons. Luckily, water will fill in the lonely gaps. The OH will bind to carbon and the H will bind to oxygen. Now, both of the atoms that were left behind are sharing electrons with another atom. This keeps these two monomers apart since they're both fulfilled. Here are some more associations that you need to learn. Breaking down is catabolism or hydrolysis. You're breaking down stuff or digesting things into smaller pieces. Building is anabolism or synthesis. You can think of anabolic steroids bulking up and making bigger muscles. That's it for today. See you in class.